Hello everyone, this is our second lecture for Chapter 10, One Sample T-Statistic Hypothesis Testing. In this lecture video, we will discuss effect size and assumptions for one sample t-tests. Remember that hypothesis testing determines whether there is a difference between sample and population mean. Also recall that when we reject the null hypothesis, we need to calculate and report a measure of effect size. We use Cohen's d as a standardized measure of effect size. The original equation included population standard deviation sigma. Remember the chart from Chapter 9 to help you determine the magnitude of an effect. An effect size d is equal to 0.2. is considered a small effect. An effect size d equal to 0.5 is considered a medium effect, and an effect size d equal to 0.8 is considered a large effect. Cohen's d measures the size of the mean difference in terms of population standard deviation. Estimated Cohen's d measures the size of the mean difference in terms of the sample standard deviation S. For sample means, estimated Cohen's d is equal to sample mean m minus population mean mu divided by the sample standard deviation S. With a t-test, it is also possible to measure effect size by calculating the percentage of variability accounted for by the independent variable. This measure, R squared, is based on the idea that the independent variable causes the scores to change, which contributes to the observed variability in the data. By measuring the amount of variability that can be explained by the independent variable, we get a measure of the size of the treatment effect. Percentage of variability explained is equal to R squared, which equals explained variance divided by total variance. So it's equal to T statistics squared divided by T statistics squared plus degrees of freedom. The interpretation for R squared is as follows. R squared equal to 0.01 is a small effect. R squared equal to 0.09 is a medium effect. R squared equal to 0.25 is a large effect. The size of an effect can also be described by calculating a confidence interval. Confidence intervals estimate population mean mu from the sample mean m. They are based on the assumption that the sample mean m should be near the population mean mu. The interval constructed defines near based on the estimated standard error of the mean Sm. Confidence intervals can confidently estimate the population mean mu should be located in the interval. The sample mean m is used to estimate the population mean mu. Confidence interval is equal to sample mean plus or minus t critical value times estimated standard error. The assumptions of the one sample t-test are the same as the z-test. We assume that the sample is selected through random sampling. The sample consists of independent observations or scores. We also assume that the population distribution is normally distributed. With large samples, this assumption can be violated without affecting the validity of the hypothesis test. I will post a video to demonstrate how to conduct a one sample t-statistic hypothesis test.